Hi, everyone. Welcome back to New York Energy Week 2024, the epicenter of global energy
Elliot,
innovation,
the guy's
where
being
industry leaders, visionaries, and pioneers gather to shape the future. This landmark event, now in its 11th year, unites the brightest minds to forge new paths and challenge the conventional boundaries of energy technology and sustainability. So, thank you for joining us here on the One Business World platform for our transformative journey that promises to inspire, empower, and catalyze groundbreaking advancements in the energy sector. So, joining us this afternoon from Washington, D.C., is Bud Collins. He is the CEO of American Energy Storage Innovations, and his topic for us here at the conference is the next generation of energy storage. Good afternoon, Bud. Welcome.
Good afternoon, Glenn. Thank you for having me.
Let me hand it off over to you, and I will join you on the backside. We look forward to your remarks and your presentation.
Okay, well, thank you very much. Today, we're going to talk about the next generation of energy storage. And really, that's all about gearing up for rapid energy storage system deployment. The thing about energy storage deployment is it takes a lot of things to happen in order for an idea or a business proposition to turn into revenue with an energy storage system. The key things about energy storage are that in order to meet our 2050 renewable goals, massive deployments of energy storage systems are needed around the world. If you look at the 2019 load data, which is old data, 230 gigawatt hours is needed to support an all renewable scenario in CAISO. That's 5.5 times the peak summer load. Remember that number, 5.5 times. The US demand is expected to almost double by 2050. Current US summer demand is 0.7 terawatts. Peak summer demand could be 1.1 terawatts in 2050. So 1.1 terawatts times that 5.5 is 6 terawatts of energy storage required to be fully carbon free. Taking into account the loads from transportation, commercial, residential, and industrial, you can see the consumption of electricity continues to rise. So how do we get to 6 terawatt hours? The energy storage dilemma is transforming to meet the 30-year critical path. For 2023 was a record year with a full 26 plus gigawatt hours installed in the United States, which is fantastic. It's more than double the year before. It's good, but in order to achieve 100% renewable energy use by 2050, an average of 200 gigawatt hours needs to be installed each year. That's roughly 1.5 gigawatt hours every other day. If you look at the math, 26 gigawatt hours over the 200, it's only 13% in 1 year. We've got a long way to go. Currently, large project timeframes are around 1 to 2 years to prepare, and installation times are anywhere from 6 to 9 months, and I've seen some go even over a year. So why does it take so long to install battery storage? What takes so long? The interconnection agreements really chew up a big chunk of the time frame that it takes from the initial desire to go and do a project to the time that you can actually do it. 44%. The vendor bidding and selection process at 17% of the time frame. The site preparation, site permitting, those things, 22% for permitting. Then you get into the actual doing of the project with your site preparation, on-site assembly, commissioning, testing, and debug. That's a smaller portion of it. It's only a sixth of the percentage of the time is related to the site installation, which really shouldn't take that long. When we look at this, so what is the installation effort? Well, site prep, your land prep, foundations, cabling, and trenching. The on-site assembly, where a lot of systems still have to be unpacked and readied. There are some systems that are still doing module and rack assembly in the field. There's the wiring and connections for the PCSs, the transformers, internal wiring and connections, and some even have to have cooling systems installed on site or filled in site. The commissioning, test, and debug, the integration of things like your EMS, the SCADA system, maybe the systems didn't arrive with fire panels or safety systems, that all has to be installed. The startup debugging, commissioning, and testing, all of that consumes way too much time. The current state of the industry versus what we've brought to market with TerraStore is a much higher energy density than what we've seen in the past. And we continue to push that high energy density. What does that do for us? It reduces the amount of land use. It reduces the amount of foundations. It reduces the amount of cable connections. All that can be done quicker. The on-site assembly activity, we don't do. The on-site assembly of our system is the system is factory assembled and tested. It requires a minimal of on-site connections and just 6 hours of assembly on site. The savings also are in that the TerraStores are self-powered, they're self-cooled and self-controlled AC battery systems. So you're really buying something that's all together. It's like if you were to go buy a car, buy the car from Ford, the engine from General Motors, and buy the transmission from Chrysler, and you put it all on site. Well, we're delivering you the full F-150 all set, ready to go. Here's the keys. The commissioning, test, and debug part of the system, I've seen that go as many as 6 months in some cases. That is a real problem because that's the time you should be in revenue service. So the commissioning, test, and debug for our system, it's already been tested. It's already safety certified, no on-site compliance certification, no integration, no debugging. And StoreView, our EMS system, can even execute the commissioning autonomously. So these are the types of things that the industry needs to do. We're leading that and pushing the industry to make the effort of installation and getting into revenue service as quickly as possible. So introducing a better way to install energy storage from 6 hours from arrival to commissioning. That's unheard of in the industry, but that's what we're going to need to do to get that 200 gigawatts per year installation to meet those goals. So the TerraStore product is a 7.9 megawatt hour at a 4-hour rate. It is density from an energy density standpoint. We can get up to 660 megawatt hours per acre when double stacked, 330 if it's just a single stack. The architecture is completely different than anything else in the industry. We've eliminated 280,000 components from comparable systems, which enhances the reliability, reduces the cost. We've the installation, as I said, on site with 22 very simple connections. We remove the risk of cell-to-cell propagation in our systems. Module-to-module propagation is not an option for us. It has to be no cell-to-cell propagation in the event of a thermal runaway. So there are no large events that happen. It's just a single cell. And it's designed, manufactured, and tested and supported as a single product. Kind of like when you put in a transformer, you set it and forget it. So summary points, getting to 100% renewables by 2050. The current state of the industry will not get us to this goal. We need to improve all aspects of storage deployment. The interconnection process is a big pain for people. It's the biggest delay. We need help there. The industry needs to move forward with better tools and modeling tools to make that happen quicker. The vendor selection process needs to be simplified. Transparency from your vendors is the most important thing you can ask for. The permitting process needs to be seamless. It needs to be done with a proactive community and develop community involvement and education, site preparation. The higher the energy density, the less site you need. The installation needs to be done very quickly, and the commissioning has to happen seamlessly. So with our way to do it, we can radically reduce all of that on-site effort per project. We must challenge conventional thinking in order to meet the needs of today and tomorrow. Thank you very much.
But thank you very much for your remarks and your presentation. Much appreciated. Everybody everybody knows math is hard, but even I could do the division too. 13% is challenging, huh?
It is. It is.
How
But,
how tight how
we
tight
need,
is that denominator, that 200?
so that's not actually, that number keeps growing because as we turn to removing fossil fuels in all these various places, whether it be in transportation, in heating and cooking, and those areas, the demand keeps going up and up. Just think about the Bitcoin mining, what that's done to the electricity demand. It's it's not only doubled and quadrupled, but sometimes tenfold more electricity usage in a given area. So as we go forward with AI, Bitcoin mining, the demand for electricity is just going to go through the roof.
On thinking about your pie chart again, almost two-thirds was either the interconnection agreements or permitting. Before you
Yes,
can do anything else, assembly, just that's amazing that two-thirds of the time is just preoccupied with. I guess it's, I mean, again, it's part of the process, but that front loading part, is that a federal? Can we how do you is that a federal? Is it a state? Is it a
it's
municipality?
it's federal. It's ISO related. It's municipality related. It's recognized as an issue. It's recognized as a problem. But the tool sets and the way things have been done in the electric generation and distribution industry are archaic. There needs to be a step change
Hmm.
in how that's done. And I know FERC is really focused on this, and there are a lot of people in the industry on both sides of the fence that really want to figure out a way to make this happen a lot faster because it needs to.
Now, in developing your solution, American Energy Storage Innovations, the Terra Store piece, how long did it take you to get to that point? Because it looks like a turn. It almost, well, what do I know? But it almost looks like a turnkey solution.
So we started in July of 2021 with my team that was with me at A123 and NEC. We got back together again after everybody left NEC, and we decided to take one more shot at it. And this time we wanted not to do what everybody has been doing in the industry. We really wanted to address those latent needs as well as the obvious needs of the customer. And it's the latent needs like installation time, commissioning, reliability, being able to count on the system, at 99% reliability and actually achieve those types of things. So we took a big list of issues, problems that we could see today and we know are going to happen tomorrow, and we tried to address those with TerraStorm.
Yeah, I mean, you think of the traditional process you laid out. You spend all that time and you're ready to go, and then you still have to then wait for certification or that process to play out. And then so you think you're ready, and then just keep adding, like you said, even some of those all the way up to 12 months, you said, on some of the installation size. That's a long time.
I was talking with a gentleman today, a customer, who had a system that they bought. They bought it from a reputable Chinese cell supplier. But that system had two or three other vendors involved in integrating all the various pieces and parts. And after months and months and months of trying to get all that to work together, They finally got it to work, and then it showed up as, oh, it's short by a megawatt hour of energy on a 3 megawatt system.
Wow.
And
Wow.
that was just because it really wasn't prepared. It wasn't balanced.
Wow, that's remarkable that it takes. Now tell me about who's the typical customer for you guys?
So our typical customer is a developer who is either going to develop a project where they have a PPA with a utility, or excuse me, they're going to go into a merchant market where they feel it's a good value proposition, good IRR. Now they may just develop the project, or they may own and operate the project. So either of those scenarios, those are our key customers.
Okay, okay. Um, Not so much government though, or like a city or
So for us, being a young company, um, having to go and deal directly with utilities, the time frame to contract, as well as the due diligence and the terms and conditions, is it would be difficult challenge for us. We're targeting right at the, and that's where all the real business is, quite frankly.
that's an interesting way to think of it too. Because you're right. Because you think about, and I've been, I'm an accountant by trade, but I've been in plenty of spots where you go through that, let's call it the extended RFP process to try to get to that ultimate engagement, and you spend such an enormous, and then all of a sudden it comes down to, well, we basically picked them because of the price. So you go through all that effort only to come back and say, okay, we didn't
It's
get that.
it,
So knowing the
yeah.
right customer to go to, then in your case, where you're going to get some impact, you're going to be in front of the decision maker. Then, right? You're not going to be stuck in some red tape
No,
as you
you
play it.
you
Got to be very impactful then.
it is, because typically we're going to be dealing with the financial side of the business, the execution side of the business simultaneously. And that's where the rubber meets the road. They're making a decision. They're committing their capital or their capital partners' capital, and that timeline has to be met, or they're not going to get their IRR. So, they're very, very invested in seeing things go well.
In getting your solution to the market, what kind of challenges have you guys come up against?
Our biggest challenge, quite frankly, has been getting through the safety approval process. We approached it with knowing what needed to be done. Heck, we were the first company when we were back at NEC to bring a safety approved energy storage system to market. There weren't even standards for it then. And we worked with TUV to get that done. So we knew what we were going into. The problem we've run into is the vendors, or the certifiers, if you will, the the NRTL test houses. They're not equipped to really do this testing. Many of them are waving their flag and touting their capabilities, but when the rubber meets the road, quite honestly, they don't have the facilities, they don't have the people, they don't have the understanding. So, that's been a real challenge, is getting things through safety approval.
That's interesting. That sounds like when a couple of years ago, I was my parents had passed away, and we were getting ready to sell the house. The amount of stuff at town hall to go through, or to find all those people, or to get on somebody's calendar just to have them come look at it and say, "Yeah, you know what? It's a garage." I mean, it
Yeah.
was just
No,
incredible.
these are very, very complex systems, and they're very complex standards. It's not for the faint of heart to go through one to regulatory approve a system like ours. You're talking multiple millions of dollars for the safety approval. And you would hope that the industry providers would be far better equipped and prepared.
Now, before we got started, you said you're getting ready to go home. You've been on the road. How often do you find yourself? How big is your team? How are you out a lot?
So today, the team is about 93 people. We have a small team in Bangalore, India. The majority of the team is in Hudson, Massachusetts, and we've got sales and sales engineering folks spread out through the United States and over in the UK. But the bulk of, I think, probably in the 70 some odd people is in Hudson, Massachusetts headquarters.
All right, terrific, terrific. Well, listen, Bud, thank you for joining us today. Great presentation. We wish you all the best and much success and continued success in helping try to solve these issues. Knock down that two thirds piece. Get the stuff in there. Have that turnkey solution and grow the greater good. So thank you for all of what you're doing
So
here in the
thank you.
market.
Thank you very much for having me, Glenn. I appreciate it. Enjoyed it.
Thank you for being part of New York Energy Week.
Thanks. Take
Safe
care.
travel home.
Bye.
Bye.